Hello, this is Mrs. Boots, and welcome back. This lesson is on compound inequalities. Solving compound inequalities looks a little crazy, but it's actually really simple and straightforward. You see, a compound inequality is solved the same exact way as the one variable equations that you learned to solve in Algebra 1. Very simple. If something's being added, to move it to the other side, you're going to subtract. If something's being multiplied, to move it to the other side, you're going to divide. Very good. So you're kind of playing opposites. There's one key difference, however. Because we have these inequality symbols, anytime I divide by negative, I have to switch that symbol so it goes the other direction. So anytime I divide by negative, I've got to switch my inequality. All right? So make a note of that. It should be in the fill in the blank at the top. That if you multiply or divide by a negative, you have to change the direction of the inequality, or you have to switch the inequality, okay? So other things that we have to remember, because they're inequalities, we are going to put the answers on number lines. And on our number line, we're using open dots and closed dots. When do you use an open dot? When you don't have the equal to. So it's just a greater than, less than, no big deal. Open dot. If it has the equal to symbols, the equal to with my greater than, less than, then I'm using a closed dot, right? Remember, we shade in the direction the arrow points. So if my x is first and my arrow is pointing to the left, I shade to the left. My arrow is pointing to the right, I shade to the right, okay? Then we're going to have to write it in interval notation. I know, it's kind of crazy, but I got to tie it together somehow, right? So we have our parentheses and our brackets. Remember, we use parentheses if it's an open dot, bracket if it's a closed dot. So the reason these are called complex inequalities is because you basically have two problems inside the one problem, okay? So notice in example 1, I have my inequality, and then I've got that or statement. Or means, look, you've got two problems here. We're just going to work it as two separate cute little problems. No big deal, right? The first one is so simple, you've probably already finished it. How would you move the 6 to the other side? You're right. You're going to subtract it. We're going to subtract that 6 to get it to the other side. So I'm going to end up with an x. I didn't multiply or divide by negative, so I still have greater than equal to. 11 minus 6 is 5. It's done. That's it. That's it on that part. Don't quit and give up and go to the next problem yet. You still got the other half, right? So we got to move the 5 first. What do we do to move the 5? Very good. We're going to subtract that 5. The 4x comes down. My inequality symbol comes down because I didn't multiply or divide by anything. Negative 23 and negative 5. Yep, negative 28. Okay? Now I need to divide by 4, so that's x less than equal to. 28 divided by 4 is 7. It's going to be a negative 7. Now, because it's a negative, do I have to switch my inequality symbol, change direction? No, it's only if I multiply or divide by negative. We didn't divide by negative. We divided by a positive, so it stays. So now here's where our number line comes in. We draw a cute little number line. We're going to put them in order. Remember, the smaller number goes on the left, so negative 7 is on the left, 5 is on the right. Now, what kind of dot is the negative 7 getting? It's a solid dot because it has an equal to. The 5 gets a solid dot because it has an equal to. Now, from the negative 7, which way am I shading? Yep, arrow points to the left, so we're going to shade to the left. From the 5, it points to the right. We're going to shade to the right. Now we're going to do our interval notation. I'm going to write it right underneath my number line. So I'm going from negative infinity all the way up to that negative 7. Negative 7's included, so I have a square bracket. Let's see if I can make a square bracket. I have my U shape because it's an or. It's at one end or the other, and they even told me that at the beginning of the problem. Then I'm going to start with 5, who gets a bracket because it's a solid dot, and go to positive infinity. And you're probably thinking, that's it? Yeah, that's it. It's that simple. And you're going, well, Mrs. Boots, you said it was compound inequalities. I thought this was going to be monstrously hard. It's not monstrously hard. But people look at it and they get all freaked out and scared, and they don't need to. It's actually very simple. We're just going to break it down one problem at a time, one step at a time. Do the first part, stop. Do the second part, stop. Graph both parts on the number line, then write your interval notation. Try and make it look neater than mine does. All right, next problem. Example 2. It has an or, okay? There's a big hint. I'm going to have 2 different pieces, and they're going to be on one end or the other. Okay, I can handle that, right? What are we going to do with that one? Yeah. You got it. We're going to add the 1 to the other side. Okay? So I end up with a 2x greater than 18. Now I'm dividing by 2. Is the 2 positive or negative? It's positive. So do I switch my inequality symbol? Do I change direction? No, we do not change direction. So I just have x greater than 9. Okay? So my number line, I know I'm going to have a 9, but I'm not going to put it on there just yet. Because I got to see what the other number is. Okay? Other half of the problem. Got to subtract the 2. Subtract the 2. Okay? So I got a 7x less than, that's negative 53. Ugh. Alright, we got to divide by 7. Mrs. Boots. 53 is not divisible by 7. That's okay. We can have fractions. Right? The cookies would not taste the same if we didn't. So it's negative 53 over 7. Okay, we don't have to plug it in the calculator. We don't have to be a rocket scientist here. Which one's the bigger number, 9 or negative 53 over 7? 9. So 9 goes on the right. Negative 53 over 7 goes on the left. You don't even have to plug it in and get a decimal. You don't need to know where it's at. Just put the 2 tick marks, okay? All you need to know is it's negative, it's on the left. Now, does it have an open dot or a closed dot? Okay, again, the number doesn't tell you it's the inequality symbol, and they're both open dots. Okay? So now which way do I shade? From the 9, I see a greater than. I got a shade to the right. And from the negative 53 over 7, we're shading to the left. Okay? So my interval notation, I'm going from negative infinity to negative 53 over 7. That's going to have a parenthesis because it's an open dot. I do my U shape, tunnel down underneath, come up at the 9, who also gets a parenthesis because it's an open dot. And now we're going to go to positive infinity. Super easy. Now number 3 is where our students really start to get upset, because there's 2 inequality symbols. All they did was take one big problem and 2 little problems and smash it together into one big problem. Just remember, okay, so if I added 1 to one side, I had to add it to the other, right? I subtracted 6 from one side, I subtracted from the other. I have 3 different parts. You can even go in and draw yourself little lines in here so that you know where those equal signs are at. Okay? So whatever I do in here to get x by itself, I have to do to all 3 pieces. So what am I going to do to get x by itself? A, get rid of the 3, right? I do that by subtracting. So I subtract 3 from the middle. That means I also have to subtract 3 on the left and subtract 3 on the right. Okay? So this is like one kid gets in trouble, they all get grounded. They were all involved in the fight, they all get grounded. It's not fair, but that's the way it works. Okay, so now we're going to come in. So we have 5 minus 3, which is 2. I'm going to drop down my inequality symbol. My x drops down, my 3's are gone. Inequality symbol drops down, 9 minus 3 is 6. Okay, did you catch that? So we subtracted 5 minus 3, Drop down the inequality symbol. My 3's canceled in the middle. All that's left is the x. Drop down the inequality symbol. 9 minus 3 is 6. Well, that doesn't look so bad. Where's the x at? It's in the middle. It's in between. This is a sandwich, right? The x is sandwiched in between 2 and 6. The 2 has what kind of dot? Closed dot. The 6 has a open dot. And where do we shade? In the middle. X is sandwiched in the middle. So I'm going to have a square bracket with my 2, and my 6 has a parenthesis. X is in the middle. I don't have any infinities because it doesn't even go there. It's sandwiched. Got 2 slices of bread, PB and J's in the middle. Right there. Example 4 is the exact same thing, just a little bit longer. Okay? So first thing I have to do is get rid of the 4. So I'm going to add the 4. All right, you guys agree? 4 is being subtracted, we add the 4. Get rid of it, right? So negative 64 plus 4. Negative 60. I'm going to go ahead and bring that symbol down. I have a 6b in the middle. 4 is gone. Bring the symbol down. Negative 22 plus 4. Fingers and toes, all right? It's negative 18. Not a big deal, okay? But now I still have that 6. Well, that's okay. What do you do? Very good. We're going to divide by 6. Okay? All 3 parts divide by 6. So I end up with negative 10 less than b less than negative 3. Very good. You're ahead of me. Okay? You're like, well, Mrs. Booth, they're out of order. No. Losing $10 and losing $3 on a number line. The 10 is still on the left, the negative 10. Negative 3 is still on the right, because we're headed towards 0. We still have our open dots, and the B is sandwiched in between, so our shading is in between. So our interval notation would be from negative 10 to negative 3. Both get parentheses because both have open dots. And this concludes the examples for our compound inequalities. They're really simple. Just make sure you remember, if you divide by negative, you do have to switch the inequality sign. You just change directions and keep on going. When do you use open and closed dots? Which way to shade? And when do you use parentheses versus a bracket? Please go ahead and start the practice problems at this time.